Hello and welcome back to Ganesh Institute channel. So in today's video we are going to discuss about Leibnitz theorem. Basically this theorem we use in order to find out the nth derivative of product of two functions. Let's say you have two numbers, okay, uv, and you have to find out its derivative. What it would be? Derivation of first and then second as it is plus derivative of another one and first one remain as it is, right? But what if you have to do derivative nth time? So then you can have this Leibniz theorem into picture. So what does it state? Let's have a look. So here you have two numbers, two functions uv, and you have to differentiate them, their product n times. So it is like binomial expansion. So you will do derivative of one function nth time, then second function as it is, and keep repeating it with the binomial expansion nc1, and keep decreasing un, and keep increasing v. So v, here is v, and then v1, then nc2 un minus 2, you decrease again this one time, and then v2, so 2 times derivative, then nc3 un minus 3 v3, and just keep going on until ncn uvn, right? Now you have only one u and n times v. So this is how you do. Let's take an example. Let's say if you have to find out the nth derivative of e raised to power x 2x plus 3 raised to power 3. So now you have to suppose two functions u and v. What your v will be? So for u, let u be e raised to power x and v be 2x plus 3 raised to power 3. Okay. So why I have assumed u as e raised to power x? Because if we differentiate e raised to power x, it is always e raised to power x, right? Even if you will, let's say u is e raised to power x, you will differentiate it one time. Your u1 will also be e raised to power x. Your u2 will also be e raised to power x. And your un will also be e raised to power x. So correct? Then you have your v with you. Now if you have to find out what you need to know about v, then v1, v2, v3, and so on. So v is with you. Now v1 is what? Differentiate of v with respect to the variable which is given. So if you consider this x cube is 3x square. So this is how. And now whatever you assumed x, which is 2x plus 3, derivative of 2x plus 3 would be 2. Correct? So your v1 is 3 times 2, which is 6, 2x plus 3 whole square. Now your v2 will be differentiate of this. So 2x plus 3, assume this as x. So derivative of x square will be 2x, right? Now whichever is assumed as x, that is 2x plus 3, its derivative is 2. And 6 is here. Correct? Let me erase this bit so that you can have the clarity. Now, if we solve this, what we will get is v2. 2 times 2, 4. 6 times 4 is 24. 2x plus 3. Correct? Now your v3 will be, so if you assume this x, so its derivative will be 2, because for 3 is the constant, it will be 0. So 24 times 2 is 48. Now if you again do v4, there is no x, no variable, so v4 will be 0, v5, every higher derivative will be 0. Correct? So there is no need to find out those derivatives. Now if we apply Leibniz theorem, so by Leibniz theorem again, if you see all other higher powers of v, v4, vn, everything will be 0. So you have to consider up till this part. Correct? So your uvn will be unv nc1 un minus 1 v1, nc2 un minus 2 v2, and nc3 un minus 3 v3. Correct? So now put this value. So your e raised to power x 2x plus 3 whole cube, which is your question, would be un. Your un is what? E raised to power x. Your v is what? 2x plus, this is your v, 2x plus 3 whole cube, correct? Plus nc1. Now you know how to solve combination, right? For nc1 you have to do n factorial divide by 1 factorial and then n minus 1 factorial, right? So you can solve it this way. If you have 5 factorial, how you will solve it? You have to keep decreasing by 1. 5 into 4 into 3 into 2 into 1, right? So you can write it as this as well, 5 into 4 factorial, because again 4 factorial is 4 into 3 into 2 into 1. So I can write it as n into n minus 1 factorial, right? Because n minus 1 factorial is n minus 1, n minus 2, and it will be moving on. And in denominator 1 factorial is 1. We have n minus 1 factorial, which will be cancelled. So what we got is n. So here this value is n, then un minus 1. So we have all the values of u1, u2, u3, un minus 1, everything e raised to power x, right? So this is n, then we have e raised to power x and v1. What is v1? This is the value. So 6, then 2x plus 3 whole square, right? Then what we have got is nc2. How you will solve nc2? So your nc2 will be, just bear with me, n factorial divided by 2 factorial into n minus 2 factorial, right? So n into n minus 1 into n minus 2 factorial, you can write it. Then 2 factorial is 2 times 1, which is 2 itself, n minus 2 factorial. It will be cancelled out. What you've got is n minus 1 by 2, correct? So this is your nc2. Now un minus 2, again all the higher derivatives of un or lower derivatives, it is e raised to power x only. Then you have v2 with you. So let me erase this bit so that we have enough space to write. So now if you see, we are writing down the values of v2, correct? So your v2 is what? This one, 24, 2x plus 3 plus nc3. What is nc3? nc3 would be n factorial upon 3 factorial n minus 3 factorial, right? Now again if you expand n, so n minus 1, n minus 2, n minus 3 factorial divide by 3 factorial into n minus 3 factorial. It will be cancelled out. So what you have got is n minus 1, n minus 2 divide by 3 factorial means 3 into 2 into 1. That means 3 to the 6. Correct? So this is your answer. You can simplify it in the sense, let's say if we take common e raised to power x. So what is left? 2x plus 3 raised to power 3 plus n into 6. That means 6n 2x plus 3 whole square. Then 2 times 12 is 24. So 12n n minus 1, right? Into 2x plus 3. This one. And then from here, okay, we haven't written here un minus 3 and v3, correct? So un minus 3 is what? Again e raised to power x. We have only written nc3, right? So this is nc3 e raised to power x, and v3 is what? 48, correct? So 6 times 8, 6 8s are 48. So this will be 8n n minus 1 n minus 2, right? 8n n minus 1 n minus 2. So this will be your answer. I hope you have understood this topic very well, and if so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.